In previous example, we assume the lives of the equipment are finite. What happens if the life of the equipment is not finite, it's just go to infinity? So to explain here, I'm going to start going back to chapter 4. When we have a present worth of a uniform payment, so this is basically what we have in chapter 4. And this is N. So you have a uniform payment of A, and you're trying to find the present worth of those payments. So this is we discussed in chapter 4. Is 1 plus I to the n minus 1 over I times 1 plus n. What happens if n goes to infinity? Again, I explained this on chapter 4. I'm just trying to review it again. So if n goes to infinity, negative 1 compared to this term is very small. So this one I can eliminate. So this is going to go away from this. So my equation is going to be very simple. P equal A over I. So basically, that's what we're going to do here when the life of the equipment or alternative goes to infinity. We're going to use the equation, which is P over A over I, which is A is your annual cost divided by the interest rate is going to give you the P value here. So under this method, what we're going to do here is we're going to call this one capitalized cost method. And which is equal to the annual cost for the alternative over interest rate. So basically, we're going to find the annual cost first, divide by interest rate. Then we're going to find, we call this one capitalized costs associated with the alternative. So we're going to use this approach to compare the alternative if the life of at least one of the alternative goes to infinity. To explain here, I'm going to start with the first problem. So we have two alternatives, alternative A and B. Alternative A has life of 7 years, but the alternative has life of infinity. So in order to do this, first we're going to represent the cash flow diagram for each alternative. So the cash flow diagram for alternative A for one cycle, that's all we need here. So you have initial cost for this one is 50,000. So 50,000 initial costs. And the life of this one is 7 years. Year 1, year 2, year 3, up to year 7. So the initial cost is 50, but in this one, the cost of operating is going to be larger than even initial cost. It can happen. So this one is 62,000. And the salvage value is 10,000. Now, this is the cash flow diagram for alternative A here. The life of this alternative is limited, it's 7 years. Now, under capitalized cost method, as I mentioned earlier, we call this on capitalized cost for alternative A. First, we have to find the annual cost for alternative A, divide by interest rate. That's going to give you the capitalized cost for alternative A. So that's why you have to find the annual cost first, then divide by I is going to give you the capitalized cost. Let's do the AUAC for alternative A. Remember, in this chapter, we convert everything uniform payment. The 50,000 is not uniform. We're going to make it uniform. 50,000 by multiply by A given P, because at the present time, you're trying to make it future at the uniform payment. And the interest rate for this example, I equal 20% per year. So 20% and 7 period. So that's going to make this uniform, the initial cost a uniform payment. Now we have 62,000 uniform. You don't have to change it. So 62,000, that's uniform. Anything is uniform, you're not going to touch it. But the last one is the salvage value, which is 10,000. And because it's a future value, you have to multiply by A given F, 20%, and 7 period. That's going to make that 10,000 uniform. Now, if you find this, the equivalent uniform annual cost, in short, we call this an EUAC, for alternative A is going to be equal to $76.80. So that's the annual cost for alternative A. We want to find the capitalist cost. We're going to divide 75,000, $96.80 over the interest rate, which is 20%. If you do this, we call this on capitalist costs associated with alternative A here. So it's going to be $375,484. What does this mean here? It means if you have this much money at the present time, you can repeat this alternative every 7 years forever. So that's why we call this on capitalist costs for alternative A here. Now we're going to do the alternative B here. Alternative B has life of infinity. It means the equipment is going to last forever if you do some maintenance. So the first thing we do is just draw the cash flow diagram for the alternative. You have the initial cost of 200,000. And then you have the annual operating cost of 24,000. And that's continue to infinity. So year 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to here say continue to infinity. So these are the costs that are going to go forever. And the size of those costs, 24,000. Now, in addition to annual operating costs, you have a maintenance cost every 6 years. So this one is 4,000. Then you have another one at the end of year 12. And you have another one years 18. And continue forever every 6 years. I'm not going to show you. This is only 2 of them. You're going to continue every 6 years. You're going to have $4,000 cost. Now we are trying to find the capitalized cost for this problem. So the way we're going to do for alternative B is going to be a little different from alternative A. The capitalized cost is nothing more than the present worth of the future costs or income. So you have 200,000 at time 0. So basically the capitalized cost for alternative B is going to be, this one is only one-time cost at time 0, negative 200,000. So basically, the capitalized cost is nothing more than the present worth method. So 200,000 at time 0 is 200,000. Then you have 24,000 uniformly paid from year 1 to infinity. For this part, we're going to use the equation P equal A over I. The present worth of uniform payment if the life of the investment goes to infinity. So that's why we're going to divide 24,000 over the interest rate, which is 20%. So that's going to give you the capitalized costs associated with the annual operating costs. Now, we have one more cost left here, which is the maintenance cost every 6 years. 4,000 here, year 6, 4,000 year 12. You have another one year 18, and so forth here. So for that part, because it's not the end of every year, you cannot use this equation directly. So what you have to do, you have to make this one uniform. So what I'm going to do is I'm trying to make this 4,000 uniform from year 1 to 6. I'm going to call this one A1, A1, A1. So that's a uniform payment. And the size of A1, because remember the future value is given, you're trying to make it uniform. It's nothing more than 4,000 times A given F, 20% and 6 period. Now remember, if I do this one for the first 6 period, I can do it for the second one, the third one, the fourth one. So that way I can make all of them uniform. So it's going to be A1, 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 and so forth. And that's going to continue also to infinity. See that? Because this payment was every 6 years, I made it uniform, which is this much. Now I can use this equation. So basically, this is going to be equal plus the A1, which is 4,000 times A given F, 20% and 6 period, divided by the interest rate. So that's going to give you the capitalized cost associated with this alternative. Remember, I'm going to repeat this. This is the initial cost, that's the present worth value. The second one is the capitalized cost associated with the annual cost. And the third part is the capitalized cost associated with the 4,000 every 6 years to infinity. So now we have the capitalized cost for this alternative. It is going to be negative 332,000. So it's going to be the the capitalized cost for this alternative. Now, if you recall for part A, we find the capitalized cost. I'm going to put it here. The capitalized cost for alternative A was $375,484. Now, if you recall, the capitalized cost for alternative A was $375,484 compared to $332,014 for alternative B. Obviously, the capitalized cost for alternative B is less than the capitalized cost for alternative A. Therefore, you select alternative B here. So it means the B is the better choice. Basically, what does mean here is this. If you want to invest alternative A, that's going to cost you at the present time $375,484. That's going to be able to maintain this alternative forever. But if you want to do alternative B, it's going to cost you $332,014, and you're going to maintain this alternative forever. So obviously, this one is lower. You select alternative B here.